Casey, in order to get this to you fairly quickly, I'm gonna roll through this directly from the reading and explain to you the constraints. I hope this is helpful. Assuming this is the problem you're talking about, so this is portfolio selection. It looks like you're trying to maximize a portfolio based on projected rates of return for several investments. And I think probably the challenging part of this is coming up with how the problem is constrained. So let me just roll through this, and again, I'll go slow here so that I don't get anybody sick. Let's see. So the investment opportunities are these 5 investments, and here are the projected rates of return as a percentage. And let's see. Management of Welty imposed the following investment guidelines, right? So when we see guidelines, these are probably things we're going to have to turn into constraints. Neither industry or steel should receive more than $50,000. Government bonds should be at least 25% of the steel industry investments. And the investment in Pacific Oil, the high return but high risk investment cannot be more than 60% of the total oil industry investment. So what are the recommendations for $1,000 or $100,000? So first of all, notice that there are 5 possible investments here, each with a rate of return. So the book gives you your decision variables here, dollars invested in Atlantic, Pacific, Midwest, steel, and then government bonds. So make sure that we know that we've got oil, we've got steel, and we've got government bonds. And I think there is a constraint for each one of those. And I think the book, let's just keep going here. So the objective function, obviously we're going to maximize the profit. These values that you see as the coefficients, if you go back up to the table right here and you turn these into decimals, so 0.073, 0.103, 0.064, so on and so forth, those become the coefficients right here in the objective function. Now, because the amount because these are stated in terms of the amount investment, which is appropriate, the first constraint that you're going to have here is A plus P plus M plus H plus G. The total amount you invest must be equal to $100,000. And Casey, what I would recommend is if you go into one of the videos and find a spreadsheet that I have provided for you for topics 3 or 4, you can set this up exactly that way if you want to try to set it up and solve it yourself. Just all you got to do is amend the decision variables, the coefficients, and then but the constraints will line up very nicely. Just putting the coefficients in the matrix below the decision variables and the coefficients, as I have done in all my Excel spreadsheets. So one more time, here are your decision variables. Here is the objective function based on the percent returns from above. And then first constraint is you only have $100,000, so the sum of all the investments must be equal to $100,000. Then it says the requirements that neither the oil nor steel industry should receive more than $50,000. So the amount invested in Atlantic Oil plus the amount invested in Pacific Oil must be less than or equal to $50,000. And then the amount invested in Midwest Steel plus the amount invested in Huber Steel must be less than or equal to $50,000. So 2 constraints so far. Then we have actually 3 constraints, 1, 2, 3. The third one says, fourth one says the requirement that government bonds be at least 25% of the steel industry investment is expressed as. So G is the amount of the investment in government bonds, and it must be at least, so 25% as a decimal is 0.25 of the total amount invested in steel, which is M plus H. And then in order to get that into Excel so that you can consider it as a constraint, notice the 0.25 is distributed to M, it's distributed to H, and then just a little algebra step here, subtract those 2 terms from the right-hand side, put all the variable terms on the left and set that greater than or equal to 0. I think I have, if you go back to the, I forget the name of it, the company that made the wine cooler, I explained, there's a couple constraints in that problem very similar to this, where I show you the math here and explain the algebra. And then finally, the final constraint is Pacific Oil cannot be more than 60% of the total oil industry investment. So P, the amount invested with Pacific Oil, must be less than or equal to 0.60 or 60% of the amount invested in Atlantic Oil and Pacific Oil. This one, a little bit different here when you get to, let's see, when you get to the algebra here. So once I distribute this 0.6a plus 0.6p, when I subtract those from the left-hand side, I have p minus 0.6p. So that's how you come up with 0.4p. And then you have minus 0.6 times the amount invested with Atlantic. And let's see. So with all that said, this is the piece right here that you will be putting into Excel. So the objective function, we've talked about that. Here are your coefficients and the decision variables. The constraints, the fact that you've only got $100,000 to invest. The total amount invested in the oil industry can't be more than $50,000. The amount invested in steel can't be more than $50,000. The government bonds must be at least 25%, as I recall, the amount invested in the steel industry. And then the amount invested in Pacific by itself can be no more than 60% of the total amount invested in the oil industry. So those are the constraints. You put that into Solver. And let's see, I think you've got some help here. Let's see, it looks like it's going to be $20,000 at Atlantic, $30,000 at Pacific. Actually, none with, who is M? I forgot who M is. Midwest Steel, $40,000 with Huber Steel, and then $10,000 in, I think it was government bonds. Let me just check that here. Yep, government bonds. So that this is going to be your optimal solution, this mix of values, and it looks like the profit from, or the interest that you're going to make, or the return on the investment, is about $8,000. And then you've got your sensitivity data here. I think let's see, what are the interesting items here? Obviously, objective function coefficients. How much can they increase or decrease without changing the optimal solution? Again, the optimal solution being the mix of the decision variables themselves. And then down here, let's see, what is typically of interest here is anything that had, or anything that has a shadow price that is non-zero. Anything that has a shadow price of non-zero means that you used up all the available funds in the investment. And then if you had more money, how much could you make, or how much would you lose based on an additional dollar, right? As long as those dollars are within these bounds, right? So in this case, an additional about, let's see, 7 cents of additional return for every dollar that you have up to, it looks like $50,000, and a loss of about 7 cents for every dollar you decrease. Let's see, that's 12,500. So, you know, where the interest comes in here is when you have the non-zero shadow prices, and then how those would influence the value of the objective function, but of course within the limits of the allowable increase and decrease. So I hope that's helpful. Go through this, read the problem again one more time in the book. If there are any specific questions, let me know and I'll be happy to answer them. Thanks.